Alright, so we're now going to move away from the basic sine function and we're going to move on to the transformed sine function. And in this case, we now introduce parameters a, b, h, and k. And these parameters are going to affect our function in pretty much the same similar way that all these parameters affected the other functions that we've looked up till now. So, for parameter a, supposing I just take my regular sine function and now introduce a. So a is going to affect my basic sine function by changing the amplitude. So in other words, your amplitude is going to be the absolute value of a. And the amplitude is actually that distance from the highest point on your curve to the halfway line, or from the lowest point on your curve to that halfway line. So in other words, it's going to shrink or stretch your graph vertically. In addition, it will also flip the function horizontally. How does it do this? Well, if a is negative, the function flips. And this is pretty much similar to what we've done for all the other functions. So the absolute value function, the parabola function. So it's always going to be flipping it in the other direction. So if I were to start off with my basic sine function, in this case, I'm just looking at my regular period from 0 to 2 pi. And now I introduce the value of a, where a is 2. Well, what I just did here is I doubled my amplitude. So rather than having an amplitude of 1, I now have an amplitude of 2. And therefore, my overall height from top to bottom is now 4, from -2 to 2, which would also be my range. What's really important to note is that a did not affect the value of the zeros. So all it did is that it stretched my function. Now, what would happen if I actually make the value of a smaller than 1? So, if it's smaller than 1, I now compress my function. So it shrinks. However, the zeros are still the same. And lastly, if I were to look at the regular function, which in this case is the purple one, so that would be my sine of x. Well, as long as I put a negative in the front, so a negative a, my function is going to flip. So rather than increasing from 0, 0, it's now going to be decreasing from 0, 0. And then as it's supposed to be decreasing, it now increases. So, as an example, what would be the amplitude of y is equal to -2 sine x? Well, the amplitude is going to be the absolute value of a, which means that my amplitude is 2. In this case, this negative that we see in our function reminds us that our function also flipped. Now this is going to be important because eventually we're going to start graphing these functions today. So, how does parameter b affect my basic sine function? Well, it changes your period. So we know that the period for the basic sine function is going to be 2 pi. But now the period for any sine function, we're going to be able to determine that by taking 2 pi and dividing it by the absolute value of b. If b is greater than 1, it will compress my graph. If b is less than 1, it's now going to stretch my graph. And if b is negative, my function actually flips. So in this case, for my sine function, there's something really special. If a is negative, I flip my function. If b is negative, I also flip my function. So in our first example, at the top, we can see that our regular sine function is in red. And if I were to put a b of 2, I am now going to shorten my period. So it's going to be 2 pi divided by 2, which means that my period ends up becoming pi. So I start at 0, 0, and I finish at pi 0. So the halfway point, which is where it flips, in this case would be pi over 2 instead of pi. Whereas if I put a b value of 0.5, or any number that would be smaller than 1, in this case, I'm going to start stretching out my function. And I want you to think of a spring. In this case, your spring is being stretched, so your period is actually increasing. So 2 pi divided by 1 over 2 would give me 4 pi. So in this case, my period is actually 4 pi. And again, if I put a negative inside, well, this negative for the b value would result in the same flip over that x-axis. So what I want you to remember from now on is that y is equal to negative sine x would be equivalent to y is equal to sine with negative x. So these are both the same thing. So whenever we have a sine function and you have a negative either as your b or a negative either as your a, it has the same type of effect on my function. So what can be said about the function y is equal to sine negative 0.5x? Well, the first thing I know is that my function is going to have a different period. So my period is going to be 2 pi divided by my b. And in this case, the absolute value of b is really important to notice because the b is negative. So I will get a value of 4 pi. So my period is 4 pi. And what else can be said about this function? Well, it flips because it is negative. Now, what about h and k? So if I have a h and I have a k, how do they affect my basic sine function? Well, in the previous video, I spoke about the starting point. So from now on, our starting point is going to be called h and k. Now, if we start at 0, 0, that would be fine. That's our basic sine function. So h and k are 0 in that case. However, if h and k are actual numbers greater than 0 or less than 0, then we make a phase shift. And h is your horizontal shift, whereas the k is your vertical shift. So, what would the graph of y is equal to sine x minus pi plus 3 look like? Well, first off, let's see, do we have an a? Yeah, it's 1, so that remains the same. Your amplitude will still be 1. What about your b? Well, your b is also 1, so your period will also remain the same. It's still going to be 2 pi. But you have a h and k. So your starting point is not 0, 0 anymore. Your starting point shifted and is now pi and 3. So you moved pi to the right and 3 up. So that's the first thing that I want you to notice about this function. Now, because a and b are both positive, nothing changed, nothing is flipped over.